Hello, my name's Stephen Hicks and today's presentation is entitled The New Eurocode 4 Design Rules for Shallow Floor Construction. First and foremost, I'd just also like to acknowledge my co-authors Matthias, Braun, Zlatko, Markovic, as well as James Way. Shallow floor, or otherwise known as slim floor construction, has become popular as it provides a shallow structural zone. It has a reduced number of beams because of the spanning capabilities of the slabs. It provides a flexibility in the layout of mechanical surfaces because they can be positioned below the soffit of the floor. And the partial concrete encasement provides fire protection to the steel beams. Although not covered in the paper, they also generally possess good performance in response to occupant-induced vibrations, and that's been demonstrated through tests on newly finished hospital floors in the UK. However, whilst many solutions are available, these have been developed as proprietary systems in the absence of specific design rules given in Eurocode 4, and therefore there's a general need to develop generic design rules at a European level that complement the existing proprietary guidance for these different floor systems, and also going forward will ensure that future slim floor systems are developed on a consistent basis. In December 2012, Mandate M515 was issued by the European Commission for amending the current Eurocodes and extending their scope. In response to this mandate, the technical committee responsible for the structural Eurocode, CEN-TC 250, produced a comprehensive work programme which was split into 4 overlapping phases. And the various phases, as well as the different project team and their tasks, is presented in this slide shown here. But for the subject that we're talking about today, it was actually project team SC4T5, which was responsible for developing the new rules for Eurocode 4.1.1 and 1.2 covering shallow floor construction and other flooring types using precast concrete units. And that work was carried out between 2017 and 2020. So project team SC4T5 basically consisted of the authors of the present paper, and its task was to establish rules based on the principles contained in Eurocode 4 and Eurocode 3 for the design of shallow floors and other beams using precast units, which was broken down into the following work packages: development of design solutions for composite beams incorporating precast concrete units, which was presented in a paper in a conference a couple of weeks ago, Composite Construction 9. It also included development of design solutions for shallow floor construction, which is the subject of today's presentation, and also there's a separate Eurosteel conference paper on the fire design by Zanon et al. It was also intended to develop a compilation of solutions into codified rules and production of background documentation for future improvements. The main deliverable from this work was a new part for Eurocode 4, or additional content for the second generation of EN 1994-11 and EN 1994-12, and how that's differentiated in this presentation is PREN basically stands for pre-standard, and that's what I'll be referring to as the second generation versions of these two Eurocodes. So the different composite slim floor beam types that are recognised in the second generation of Eurocode 4 are shown schematically on the left hand side. They can be open or closed cross sections, which are either hot rolled or welded. They need to be embedded or partially embedded and act compositely with the slab, and the slab can either be solid in situ concrete, precast concrete, or a composite slab with profiled steel sheeting. And a special design consideration for slim floor beams is when they support a special type of precast unit known as hollow core slabs. And in this situation, they can be susceptible to flexible supports, which results in a reduction to the shear resistance of the slab from the development of transversal shear stresses. Instead of providing specific rules for this particular case, reference is made to a product standard EN 1168, which looks after hollow core units. It has been shown that slabs that possess a significant bending stiffness provide a much larger effective width than for traditional downstand composite beams. However, during the project team's work, it was found that there was insufficient data to enable general design rules to be developed, and as a consequence of this, a conservative approach is proposed by using the existing effective width rules in Eurocode 4. Also, during the development of the design rules, no information on the rotation capacity at plastic hinge positions was able to be found to enable a simple design rule to be developed. Therefore, it's currently left to the designer to demonstrate whether sufficient rotation capacity exists when plastic global analysis is used, and to remedy this situation, future research is needed. When considering ultimate limit state conditions, a consideration that's particular to slim floor beams is that the plastic neutral axis typically lies quite deep within the cross section. In this case, the plastic bending resistance can overestimate the actual resistance. In these circumstances, the bending resistance should be evaluated from non-linear theory using the stress-strain relationships of the concrete, structural steel and the reinforcement bars. But because that can be quite tedious for designers, a simplified method for evaluating the non-linear bending resistance is proposed in the new rules, where within a defined scope, which is given in the paper to this conference, the design plastic bending resistance of the composite cross-section with full shear connection is multiplied by a reduction factor beta SF, and the relationship between beta SF and the position of the plastic neutral axis is shown on the graph on the right hand side. So as you can see, as the ratio of ZPL over H gets larger, there's a more significant reduction to the plastic resistance of the cross section. For ZPL over H values greater than the limit shown on the right hand side of this slide, the elastic bending resistance should be used in design, or alternatively, more advanced calculation of the non-linear resistance to bending may be undertaken by the designer. Another ultimate limit state consideration is the design of the shear connectors and additional potential surface for shear failure around the slim floor beams. As far as shear connectors are concerned, they could be headed studs or transverse bars passed through the web. For the headed studs, they can be welded to the top flange of the slim floor beam or welded to the web, and for the latter case, this is sometimes known as horizontally lined studs, and rules for those already exist in Eurocode 4 Part 2. For transverse bars, they've been used quite frequently in the past, but no rules have previously been given in Eurocode 4. And from research undertaken since 2006, the following equation is proposed in the forthcoming second generation of Eurocode 4. So basically it's just considering the shear strength of the reinforcing bars. And this rule is applicable for reinforcement bar diameters between 12 and 20 millimeters in diameter, and reinforcing bars with ductility class of B or C. As in conventional composite construction, transverse reinforcement bars are normally required to prevent longitudinal shear failure of the slab, and in addition to the existing potential surface for shear failure, some additional planes are introduced as shown on the bottom right hand side of this slide. The floor is normally required to provide diaphragm action in order to transfer wind loads to brace walls or concrete core walls, and the same measures is also appropriate to achieve robustness as defined by EN 1991-17. The steel beams around the perimeter of the building should be tied into the floor plate for diaphragm action, and for torsional resistance if they support cladding. The steel beams may also be considered to act as peripheral ties. In the special case of slim floor beams supporting precast hollow core slabs, the recommended location of these ties are shown on this slide here, and these are taken from the IPHA ECCS guide. So in conclusion, the design rules presented here for shallow floor construction are now being proposed for inclusion within the second generation of Eurocode 4. It's intended that the rules complement the existing proprietary guidance for different floor systems that are currently used widely across Europe, and also set the scene for future developments. However, during the development of the proposed design rules, it's found that there was sometimes little or no data available in the public domain for certain design considerations, such as effective width of compression flanges and rotation capacity at plastic hinge positions. To remedy this situation, the project team would encourage future research in these areas. To date, comments have been received from the 34 national standard bodies, or NSBs, of CEN membership, and are being addressed by the phase 3 to 4 project teams, which are SC4, T6 and T7. And it's expected that the design rules for shallow floor construction will be incorporated within the second generation of Eurocode 4.1.1 and 1.2 as new annexes, rather than a new part to complement Eurocode 4. So thanks very much for your attention. Happy to answer questions, but if you'd like to send me any further questions, this is my email address. Thanks very much for your attention.